In this example, we want to solve 1 over x plus 2 equals 4 over x squared minus 4 minus 1 over x minus 2. And we will see that this one actually doesn't have a solution. So let's take a look at how that's possible. Let's bring up the steps on solving these rational equations. Okay, step 1 is to find the LCD. Step 2 then is to multiply both sides by that LCD and clear fractions. First thing we need to do before we find the LCD, though, is factor that x squared minus 4. Alright, well, x squared minus 4 is x plus 2, x minus 2. Now we can proceed to get our LCD. Right, LCD, we just start with the first denominator, x plus 2. Then we ask, what do we need to add to that to ensure that we include everything in the second denominator? Well, it looks like we have to add an x minus 2. We already have the x plus 2. Then we move on to the third denominator. Well, x minus 2 is already included in our LCD, so that should do it. X plus 2, x minus 2 is our LCD. Great. Now we clear fractions by multiplying both sides by that LCD. So here we go, x plus 2, x minus 2 on both sides. All right, getting a little tight over here on the left, but x plus 2, x minus 2. That doesn't look like it, but it's multiplying here. Here on the left, those x plus 2's cancel. That leaves us simply with 1 times x minus 2. All right, equals. Now on the right, we distribute this x plus 2, x minus 2 through to both terms. And notice in this first one here, it's going to cancel out this entire denominator. So we're left with simply 4 minus, and in the second term, the x minus 2's cancel, but we're left with the x plus 2. So 4 minus parentheses x plus 2. So it's important to remember when you multiply these entire terms through to keep the parentheses on. Notice if we drop the parentheses accidentally, this would be a totally different expression. Alright, so let's keep going here. X minus 2 equals 4. I'm going to distribute this negative through, so minus x minus 2. Alright, let's bring all the x's to the left side. So I'm adding x to both sides. That gives us 2x over here. And I'm going to add 2 to the right side. Well, that would just cancel this negative 2, and we're left with just 4. So we have 2x equals 4. Divide both sides by 2 to get x equals 2. Right, and it seems like that's a perfectly fine answer. But remember, we have to check these, and look what happens. When we plug in 2, for instance, right here, if we plugged in 2, we'd get 1 over 2 minus 2, which is 1 over 0. No, can't have that. That's either going to be infinity or negative infinity, depending upon how you approach it, but it's certainly not any kind of finite answer that we're looking for here. So we can't have this. We have to toss it out. There's no other solutions to choose from, so that means there's no solutions to this equation. So we either write no solution, that's one way. Okay, we can write that, or you can write the empty set. Right, the empty set is the set. What we're signifying here is the set of all our solutions. Well, we have no solutions, so that set is empty, so we just write the empty set.